This is video 252. In this video, our goal is to be able to find the number of factors of a polynomial and write a polynomial from a situation. So this is going to kind of wrap up what you've been doing with all the synthetic division and finding roots, but we're going to give you some tricks to do so after you've worked out that process. So the first trick is Descartes' rule of signs. This rule will help us determine the number of positive and negative real zeros in a polynomial. It takes a little trick and you have to get it memorized, but it is a nice thing to know so that you know what to guess. So you don't have to waste your time guessing roots and then finding out you're wrong. So the trick is to count the number of sign changes for f of x and negative f of x. F of negative x, excuse me. So what I'm going to do is I'm going to start by doing that in what I have right here. So we're going to count the number of sign changes right here. If you notice, there are no sign changes because everything's positive. So what we do is we typically jump from one term to the next and test for sign changes. And we see there aren't any. Okay, so we have 0 for the number of sign changes. So I take a look at the information here, and because of the sign changes is 0, that means there are going to be 0 number of zeros, because the rule states that the number of zeros is the number of sign changes, or less that number by a positive even integer. So it's either 0 or less than 0. Well, obviously you can't have a negative number of roots, so there are 0 positive roots. So that's nice. Now we can eliminate all the positive guesses and make a guess on a negative. So now let's test for negatives. We need to look at f of negative x. So what I do is everywhere I see x, I'm going to put a negative x inside. So negative x to the third plus 2 negative x squared plus 5 times negative x plus 4. Then I'm going to go about carefully simplifying here. Okay, I'm going to carefully simplify and see what I get. So I know a negative to the third power will create a negative. Okay, it will create a negative value. And then I test here. Well, a negative squared will actually give me a positive value. So this will stay as positive 2x squared. And then a negative times 5x will be a negative 5x. And then plus 4. Now this one's going to be a little bit more interesting. When I look at the sign changes here, I'm going to see one sign change because it went from negative to a positive. So there's one. Here's the second. And here's the third. So we have 3 sign changes. And what that means is that tells me the number of negative roots. Okay, because it's 3 sign changes, the number of negative roots will be the number of sign changes or less that number by a positive even integer. Okay, so either we have 3 negative roots or only 1. But now I know what to test. Now I know I can test any negative guess. Okay, so we're still going to make those guesses like we've been doing, but we know what to test. We know to test only negative roots. We're not going to test any positives. So I'm just going to take a look at that with you and why that's nice. Okay, when I look back to my original function, I can remember how to find the different roots. I'm going to make a list of the possible roots by looking at the constant and the coefficient of the highest degree, and I see the possible roots are plus or minus 1, 2, and 4. Well, I can eliminate all the positives, so my list becomes shorter. It's either negative 1, negative 2, and negative 4. So I only have 3 things to test. I only have negative 1, negative 2, and negative 4. My list has really shortened down because of this fact. So now if I test negative 1 into my synthetic division, drop the 1, multiply, multiply, multiply. I see negative 1 works. Okay? I still only, so negative 1 is a root. I still want to test one of those 2. But let's think about it. If negative 2 works, by Descartes' rule of signs, if negative 2 works, then negative 4 must work as well, because there must be 3 negative roots that are real numbers. So we won't have any imaginary if negative 2 works. So I only have one more thing to test. So I'm going to test negative 2 using my quotient here. Drop the 1, multiply, negative 2, of course, add. Let's see, adding, I get negative 1, multiplying, I get 2, adding, I get 6. So it looks like negative 2 doesn't work. So if negative 2 doesn't work, then that means that negative 4 won't work. So that's the positive real roots that I have. So I've already tested all that I can, but notice we're already at the point where this quotient is a quadratic. So we have options such as quadratic formula. So if I want to find the zeros, I can use the quadratic formula at this point. So this helps me narrow in on my focus on what I want to test. So you're going to give this a shot with one of the checkpoint problems. Let's take a look at one more thing that's important to help you. Here's a couple of properties that you'll want to keep in mind and maybe jot down for future reference. If a polynomial has degree n, then it has n roots. That's the bottom line. They may not be 0, they may not be real numbers, they may be imaginary roots, but for sure if we have a degree to the 3rd power, we have 3 roots. Maybe 2 of them are imaginary, okay, but they will have for sure 3 roots if it's a 3rd degree. Now, the next thing that's nice is if you have one imaginary root, that's a complex form, standard form of an imaginary number, complex number, then this is also a root. So if we have a plus bi as a root, then a minus bi is a root. That clue is important to help you. They're always going to come in pairs. When imaginary numbers are your roots, then they're going to come in pairs. So when we try to answer a question like that, we need to know those 2 facts. Okay, when we're trying to answer a question like this, we have to know these 2 facts. The goal is to find a 4th degree polynomial. So because of that first fact, since it's 4th degree, I know it has 4 roots. Now I got to figure out what those roots are. The next thing it tells me it has roots negative 2. So that means one root is x plus 2, one factor of this polynomial. The next one is x is 2. So that means it's x minus 2. The next one is I, so that means x minus I. I'm missing a root. So now I need to think carefully about which one of these properties. Notice this property right here tells me that if a plus bi, in this case a is 0 and b is 1, so it's a plus 1i. A plus 1i. Then 0 minus 1i, so negative I will also be a root. So it looks like x plus I will be a root. But we typically don't write a rule with I, so I'm going to rewrite this. I'm going to leave these 2 roots in factored form, so I think it'll be faster to calculate. But I'm going to multiply this out, so we're going to get x squared. Okay, notice it's a conjugate of one another, so the outer and the inner term will cancel. That's a positive ix, negative ix. But then we'll have minus I squared. Remember, I squared is just negative 1. So really minus a negative 1 or plus a positive 1. So that simplifies it to something simpler. Think about whether or not if you solve that, would you get I and negative I if you were to solve that and see where that is 0. So this is our polynomial. However, we haven't incorporated the final facts here. So let's take a look at this last fact. F of 3 is 150. So if f of 3 is 150, that means when I plug 3 in, here, 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 I should get an answer of 150. So think about what we're missing here. Oh, sorry. Think about what we're missing here. We're missing the fact that when we plug in 3, we should get 150. So f of 3, we should get 150. So I'm going to see what I get. Looks like I'm going to get 5 times 1 times 10. I'm only going to get 50. I need to get 150. So think about the one thing that we're missing is this constant term in front, this multiplier, the stretch factor. So f of 3, the only way to get 150 is if, let's see, I'm going to get 50 here. So it must be a negative 3 times all of this in order to get negative 150. So my rule is really this. This is my rule. because the multiplying factor does not affect the zeros. It simply affects the stretch factor, so anything that's not zero. Okay, think about a graph. You can have many graphs that have the same 3 zeros, but this graph could go much higher. That's your stretch factor. That's your A value. We call that A. So there's 2 steps to this. Number 1, writing out the factored form of the polynomial, and then using this one value to help you find the A value. So this is going to be your goal and your checkpoints, so give them your best shot and use this in your assignments so that you can quickly find things, find roots and equations of lines. So bring in your questions and your checkpoints into class the next day.